Namaskaram students. The lesson is D block elements. Another name for this one, transition elements. We are going to learn some important compounds in D block elements. They are potassium dichromate and potassium permanganate. Under this compound we are going to learn preparation, physical properties, chemical properties and uses. Rest of the lesson in PPT.
D block elements are act as a catalyst. If you used catalyst in the reaction require low energy and the wastage production also minimized, and it enhance the catalyst enhance the convert the reactant to product very easily, so that the catalyst reaction are preferred. Now how the D block elements are act as a catalyst we are going to see. In D block elements there is available d orbital is present. They accept the electron from the reactant molecule and form a bond between the reactant, so that they act as a catalyst. Afterwards the bond is breaked, so we get the catalyst once again. For example, in alkene means ethylene CH2 double bond CH2. When it react with the nickel in presence of hydrogen, it gives the ethane, because the hydrogen is, first of all, the hydrogen they break the sigma bond is break, and then it form a bond with the nickel. Afterward the hydrogen break once again and they form the bond with the partially broken pi bond of the alkene. In alkene there is a two bond is present, double bond. One bond is sigma bond and another bond is pi bond. You know very well. The pi bond is broken. That broken pi bond with the hydrogen already have the bond with the catalyst. Once again the bond is broken with the catalyst and it formed a bond with the alkene. In the manufacture of sulfuric acid from sulfur trioxide, first of all the sulfur dioxide is changed as a sulfur trioxide in the presence of vanadium pentoxide. Here the vanadium pentoxide is reduced to vanadium fourth oxide in this reaction. Then another reaction, hydroformylation of olefin. First of all, propene propene is added with the carbon monoxide and hydrogen. In the presence of dicobalt octocarbonyl, it gives butane 1-ol and 2-methyl propane 1-ol. The second one, preparation of acetic acid from acetaldehyde with the help of carbon monoxide. In presence of rhodium and iridium complex, it gives acetic acid. And next one, Zeisel Norta catalyst, a mixture of titanium, tetrachlorotitanium and trialkyl aluminium. When the propylene is with the help of this Zeisel Norta catalyst, it undergo polymerization and gives polypropylene. See the equation in the product side. In all this reaction, the transition elements are act as a catalyst. First of all, a vanadium, second one cobalt and rhodium, iridium, titanium, all these one are D block elements. They are act as a catalyst. Transition metals forms alloy. What is alloy? When the metal are joined together, one or more metal are joined together, it gives alloy. In that alloy, bulk metal, which one having more amount, that is called as solvent, and which one having small amount of metal, that is called as solute. And the alloy formation, one rule is given, that is Hume-Rothery rule. Which one satisfy this rule, they form the alloy. The first condition, the difference between the atomic radii of solvent and solute should be less than 15%. Then next one, second one, the same which one having same crystal structure. And third one, which one having same valency. And fourth one, which one having electronegativity difference must be close to 0. The electronegativity difference should be having the 0 value. So these four conditions, which one satisfying, that metals they form the alloy. And in that alloy the atomic sizes are similar, so that one metal atom can be easily replaced by another metal atom in the crystal lattice. and then the bond between the metal in the alloy are hard, so that they have high melting point. An example for alloy is ferrous alloy, gold copper alloy, chrome alloy. Formation of interstitial compound. See the diagram. In this diagram, the metal having some interfaces. In that interfaces, the hydrogen gas molecules are occupied. They are called as interstitial compounds. In that interstitial compound, in between the metal lattices, small atoms like hydrogen, boron, carbon or nitrogen, they are trapped in that interstitial holes. So they are called as interstitial compounds, and they usually have the non-stoichiometric proportion. See the example in titanium carbide, titanium and carbon having 1:1 ratio, that is titanium 1 and carbon 1. But in zirconium hydrate, zirconium proportion is 1, but hydrogen proportion is 1.92. And manganese nitride, here manganese proportion 4, nitrogen proportion is 1. So they are in non-stoichiometric proportion. And because when the elements occupy the metal lattice, they show some new property. What are they means? They are very hard when compared to the pure metal, and they conduct the electricity and then heat, and the melting point is also somewhat higher than the pure metal. When the metal is form the interstitial compound with hydrogen, they called as metal hydrate. They act as a powerful reducing agent. When the metal form the interstitial compound with the carbon, they are called as metallic carbide, and they act as a chemically inert. They chemically inactive, so that property also useful one. And the next one, formation of complex. We have already learned coordination compounds. In that coordination compound, transition metal alone act as a central metal. Why they are act as a central metal means because of their small size and highly charged, and they possess vacant low energy orbital. In that vacant low energy orbital, they accept the electron pair from the ligands, so that they form the coordination complexes. For example, hexacyanido ion and hexaamine gopal, etc. Now we are going to learn some important compound in transition element. Before that, oxide. How it is formed oxide means the metal when react with the oxygen at high temperature, it form metal oxide. In transition element, except the scandium, all other transition element form the ionic metal oxide. What is ionic metal oxide means? When it is dissolved in water, the metal oxide form ions. But except scandium, all other forming ionic metal oxide I told. In scandium, they form covalent. What is why they are covalent means? Because in water they never form ion, and also they never dissolve in water, so that they are forming covalent oxide. And also the oxidation number is increases from +2 to +7 in the transition elements. When the oxidation number increases, the ionic character slowly decreases. For example, in manganese, we know very well the oxidation number is +2 to +7. In higher oxidation state, in manganese heptoxide, the oxidation number is +7. It is in higher level. So Mn2O7 is a covalent character. The next one, higher oxides also forming the acidic character. In Mn2O7, that is manganese heptoxide, when it is dissolved in water, it gives permanganic acid formula HMnO4. The same way, in chromium trioxide, the chromium oxidation number is +6. It is also in higher oxidation state. So it gives in water chromic acid, that is H2CR2O4, and dichromic acid H2CR2O7. But in lower oxidation state, sometimes they are giving amphoteric. What is amphoteric means? It is both it gives both the acid and then base. Next one, in lower levels, for the example amphoteric chromium trioxide, here the chromium oxidation number is +3. The next one, in chromium 2 oxide, the oxidation number is +2 for chromium, formula is CrO, Here the oxidation number is lower oxidation number, so it form basic in nature. One of the important compound in transition element is potassium dichromate, formula K2CR2O7. It is prepared from the chromate ore. Formula is FeOCr2O3, that is ferrous oxide and chromic oxide. It is a oxide ore, so that the concentration method we are following here is gravity separation. The next one, the chromate ore is mixed with the excess of sodium carbonate and lime, and it is roasted in the excess of air up to 900 to 1000 degrees Celsius in reverberatory furnace. That sodium carbonate reacted with the chromate ore gives sodium chromate, formula Na2CrO4, and then the ferrous oxide in chromate ore is oxidized to ferric oxide, and in carbonate ore we are using here, so carbonate salt is we are using here, so that it gives carbon dioxide gas. Then the roasted moss now treated with water to separate the soluble sodium chromate, so that now we are getting the sodium chromate, soluble solution of sodium chromate. That solution is now yellow color. Then it is treated with sulfuric acid. Then the sodium chromate now changed is a sodium dichromate, Na2CR2O7, and the sodium chromate containing the sodium reacted with the sulfuric acid gives sodium sulfate is the one of the product along with the water. Now the above solution again concentrated to remove the less soluble sodium sulfate. Now the concentrated solution containing, after the cooling we get the sodium sulfate with 2 moles of water as a crystal. Now the saturated solution containing sodium dichromate is mixed with potassium chloride. The sodium in the sodium dichromate is replaced by potassium of potassium chloride, so that we are getting potassium dichromate. Along with it, the sodium combined with the chlorine, we get sodium chloride. Potassium dichromate is a orange red crystalline solid. See the diagram, it is a orange color, and then it is moderately soluble in cold water, but in hot water it is very much soluble. On heating it gives chromium 3 oxide along with the molecular oxygen, and it gives potassium chromate, formula K2CR2O4. It is yellow color. Potassium chromate is yellow color, potassium dichromate is a orange color. And also on heating it emits chromium, it is a toxic one, so it is replaced by sodium dichromate. Structure of chromate, see that CrO4 2-, here the chromium containing 4 oxygen, it is tetrahedral structure. The next one, structure of dichromate, formula is Cr2O7 2-. The chromium, each chromium having 3 oxygen, and 1 oxygen is shared between 2 chromium atom. And then that both chromate and dichromate, they are moderately strong oxidizing agent. Then they have the oxidation number +6, and in aqueous solution they are interconvertible. Now see that potassium dichromate in basic solution it changed into potassium chromate, and in potassium chromate in acidic solution it is changed into potassium dichromate. Potassium dichromate is a powerful oxidizing agent when it is present in the acid. The acid means what? It gives H plus ion. It gives H plus ion, so that in potassium dichromate we are split into 2K plus and Cr2O7 2-. Now we are going to take the Cr2O7 2- alone. Here the chromium oxidation number is +6. See the box reaction, and then the H plus we are getting from acid. Here the chromium gets 6 electron and reduced to chromium 3+, and H plus get the oxygen from Cr2O7 and become a 7 moles of water. This chromium 3+ and 7 mole of water is a common product in all the oxidizing reaction. Let's see the oxidizing action of potassium dichromate. by some examples. The first one, the ferrous. Ferrous means Fe2 plus. The ferrous salt get into oxidized to ferric Fe3 plus, and all other the remaining product chromium 3 plus and 7 mole of water we are getting as a common one. The next one, when the potassium dichromate in acid medium react with the iodide ion containing -1, the iodide is now oxidized to iodine. In iodine the oxidation number is 0. So -1 to 0 means it will get into oxidize. The iodide ion is get into oxidize. And the same way in sulfide. Sulfide means it contain S2 minus. It is oxidized to sulfur. Sulfur containing 0 oxidation number. So -2 to 0 means it is get into oxidize. The same way in sulfur dioxide. In the potassium dichromate in acid medium, it oxidizes to sulfate ion. Sulfur dioxide containing how many oxygen? 2 oxygen. In sulfate ion, we are having 2 more oxygen. So it get into oxidize. The next one, stannous salt. Stannous mean is Sn2 plus. In the presence of potassium dichromate in acid medium, it get into oxidize to stannic. That is Sn4 plus. So 2 plus 2, 4 plus means it get into oxidize. That is oxidation number increases. When it is oxidation number increases mean it is oxidized. The next one, potassium dichromate and then sulfuric acid when react with the ethyl alcohol or ethanol, we get the product potassium sulfate, chromic sulfate, along with that 11 mole of water and then ethanoic acid. Now see that in ethyl alcohol I strike out one hydrogen H2, and instead of that hydrogen one more oxygen is added. So the removal of hydrogen and addition of oxygen is we called as oxidation. So ethyl alcohol here oxidized to ethanoic acid with the help of acidified potassium dichromate. Chromyl chloride test. This test is used to find out the chloride salt in the inorganic qualitative analysis. We confirm the presence of chloride ion by this test. When the potassium dichromate is added with any chloride salt, here we are going to take the sodium chloride along with the concentrated sulfuric acid. It gives potassium bisulfate, that is KHSO4, sodium bisulfate NaHSO4, and then chromyl chloride CrO2Cl2 and 3 moles of water. The color of the chromyl chloride is orange red vapor. Then the vapor is dissolved in sodium hydroxide. It gives sodium chromate Na2CrO4 along with the sodium chloride and 2 moles of water. Again that sodium chromate is added with the acetic acid and also lead acetate. Lead acetate formula is given CH3COO twice Pb. It gives lead chromate. Lead chromate is a yellow precipitate, and along with that we get sodium acetate. So that yellow precipitate is the confirmation for the chloride salt. This is called as chromyl chloride test. Important question is. And then uses of potassium dichromate. It is used as a strong oxidizing agent, and it is used in dyeing and printing, and then leather tanneries for chrome tanning, and the estimation of iron compound and iodide. Another important compound is potassium permanganate, formula KMnO4. That KMnO4 we are obtaining from pyrolusite. Formula for pyrolusite is MnO2. First, the powdered pyrolusite is fused with potassium hydroxide in the presence of air or any other oxidizing agent like potassium nitrate or potassium chlorate. Now see the reaction. Pyrolusite ore along with the potassium hydroxide and oxygen gives potassium manganate. It is green color, and then 2 moles of water. The potassium manganate we are splitting as K plus and then MnO4 2 minus. Then this potassium manganate we are going to change as a potassium permanganate by using two types. One is chemical oxidation method, another one is electrolytic method. In this slide we are going to see the chemical oxidation method. First, the potassium manganate, how we split K plus MnO4 2 minus. Now take the MnO4 2 minus alone. That MnO4 2 minus is reacted with the ozone in the presence of water. That MnO4 2 minus is changed as a MnO4 minus, that is permanganate ion, and along with we get 2OH minus, and then the ozone is get reduced as O2. The next one, suppose we are adding with the manganate ion chlorine, means we get the equation MnO4 minus and Cl minus, that is chlorine is changed as a chloride ion. Next one, electrolytic oxidation of potassium manganate, that K2MnO4 is in the aqueous solution. Aqueous means what? Water, and in the presence of little alkali, when it is electrolyzed, it gives the K2MnO4 split into 2K plus and MnO4 2 minus. The minus character goes to anode because anode is a positive character, and water split into H plus OH minus. The H plus goes to cathode because cathode is a minus character, and then the first reaction we are having K plus in the product side, and the second equation we are having OH minus in the product side. Both the one combined with each other, it gives the KOH. And then now see the anode, which one is going to anode? MnO4 2 minus is going to anode, that is called as manganate ion. It is green in color. Now it is changed as a purple color on giving the 1 electron to anode. Now in the cathode side, which one is going? The H plus. So H plus, 2 H plus, 1 H plus gaining 1 electron from the cathode. Here 2 H plus gaining 2 electron, and then it formed the hydrogen molecule. That hydrogen molecule is a gaseous form, so it is liberated at the cathode. The purple color solution we are getting in the anode, that is concentrated by the evaporation, so that we are getting potassium permanganate after cooling. Physical properties of potassium permanganate. The color of the potassium permanganate is a dark purple crystal. Now see the diagram. In that one, it is a dark purple color, and in water it gives dark purple color solution, and it is in cold water it is strongly soluble, but in hot water it is fairly soluble. Then structure of permanganate ion, it is a tetrahedral structure, and the oxidation number of manganese here is plus 7, and hybridization is sp3 hybridization. And chemical properties, first one, when on heating, that potassium permanganate decomposes and gives potassium manganate K2MnO4, and along with that manganese dioxide MnO2, and then oxygen. Potassium permanganate, when it reacts with the cold concentrated sulfuric acid, it gives manganese heptoxide formula Mn2O7 along with the potassium bisulfate KHSO4 and 1 mole of water. The manganese heptoxide once again decomposes as manganese dioxide and oxygen on heating. It is an explosive reaction. And then when the potassium permanganate, it is reacted with the hot concentrated sulfuric acid, it gives manganese sulfate MnSO4 and K2SO4 potassium sulfate and 6 moles of water and 5 moles of oxygen. And oxidizing property, the potassium permanganate is a strong oxidizing agent, but in a different medium it gives different product. Now see the in neutral medium. First of all, the KMnO4 we split as a K plus MnO4 minus. Now take the MnO4 minus in neutral medium. It is reduced to MnO2, that is manganese dioxide. Here the MnO4 contains 4 oxygen, but MnO2 contains 2 oxygen. That is 2 oxygen is removed. So removal of oxygen is called as reduction. And one more thing, in MnO4 minus it gains 3 electron. So gaining of electron is called as reduction also. Now that main reaction is MnO4 minus get 2 moles of water and then 3 electron. It changes as the manganese dioxide and 4 moles of OH minus. It is a common product. Manganese dioxide and 4 moles of OH minus is a not 4 moles. The OH minus and then MnO2 are common product. Now see that now we see the example for that. First of all, that potassium permanganate, it oxidizes the hydrogen sulfide to sulfur. In hydrogen sulfide, the oxidation number of sulfur is -1. The sulfur, the oxidation number is 0 because it is elemental state. So -1 to 0 means the oxidation number increases. So the hydrogen sulfide is oxidized to sulfur with the help of potassium permanganate. Then in the second one, the thiosulfate means S2O3 2 minus. This changed into sulfate. See the product side SO4 2 minus. Here the thiosulfate contain 3 oxygen but sulfate contain 4 oxygen. So one more oxygen is added. So addition of oxygen is called as oxidation. So thiosulfate is oxidized to sulfate with the help of potassium permanganate. In alkaline medium, potassium permanganate gain 1 electron and it changed as a manganate ion. See the first equation, MnO4 minus and then 1 electron, it changed as a MnO4 2 minus. And once again the MnO4 2 minus with the help of some other reducing agent in 2 moles of water and it gained 2 more electron and it changed as a MnO2 manganese dioxide and along with the 2 OH minus. Now we are going to add these two equation. The product side what we are having in the first equation manganate ion, the same manganate ion present in the second equation in the reactant side, so cancel with each other and adding both the equation we get MnO4 minus 2 moles of water and 1 electron in the first equation and 2 electron in the second equation, we get 3 electron. Now in product side we get manganese dioxide along with 4 moles of OH minus. This reaction is a similar reaction what we get in the neutral medium. The next one, Bayes reagent. It is important question. What is Bayes reagent means? The cold dilute alkaline KMnO4 is called as Bayes reagent. We have already learned this one in the 11th standard. This uses of this Bayes reagent is we identify the unsaturation. Unsaturation means whether it is a double bond or triple bond. Now ethylene formula CH2 double bond CH2. Here if it undergo oxidation with the help of water, it gives ethylene glycol, formula CH2OH. Another name is ethane 1,2 diol. The MnO4 minus in the presence of dilute sulfuric acid, it acts as a very strong oxidizing agent and it get into reduced with the help of 5 electron. It gain 5 electron, the MnO4 minus changed as a Mn2 plus, but it oxidizes the other compound. Let's we see the example. Before that the main reaction is MnO4 minus that 8H plus, that H plus we get from dilute sulfuric acid and 5 electron. Now change as the product side. What product we are getting? Mn2 plus, it is a common and then water also common product. Let's we see the example. First one, ferrous salt means Fe2 plus, that ferrous salt changed into ferric means product side we see that Fe3 plus with the help of that acidified potassium permanganate. Then other product are same one, Mn2 plus and then water. The next one, iodide ion. Iodide means I minus changed as a iodine I2. The oxidation number is 0. So -1 to 0 means the oxidation number increases. So iodide ion is oxidized to iodine with the help of potassium permanganate. Then third one, oxalic acid. Oxalic acid, we are going to take the ionic form COO2 minus, that is oxalate ion. Here the oxidation number is 2 minus. In carbon dioxide the oxidation number is 0. So -2 to 0 means it is increases. Oxidation number increases means it get into oxidized with the help of KMnO4. the remaining product are same. And fourth one, the sulfide is S2 minus changed into sulfur, that is oxidation number is 0 for sulfur. So 2 minus 2 0 means it is also get into oxidize with help of acidify KMnO4. And fifth one, nitrate means NO2 minus, and nitrate changed is to nitrate NO3 minus. Nitrate we have 2 oxygen, in nitrate we have 3 oxygen, so one more oxygen is added in the product side, so it is also getting to oxidize with the help of KMnO4. And sixth reaction, see the ethyl alcohol changed into SCH3CH2O. Here the one of the hydrogen is removed, so that we are getting CH3CH2O, that is acetaldehyde with help of acidified potassium permanganate. So acidified potassium permanganate, it removes the oxygen, so remove the hydrogen, so removal of hydrogen is called as oxidation, so that ethyl alcohol changed into acetaldehyde. The next one, seventh reaction, in sulfate SO3 2 minus, it is changed into sulfate SO4 2 minus. Here also one of the oxygen is added with the help of acidified potassium permanganate. Uses of potassium permanganate, it is also a strong oxidizing agent, and it is used as a medicine for skin infection and fungal infection of the food. And in water treatment we used this compound to remove iron and hydrogen sulfide from the well water. And Bayes reagent, what is Bayes reagent means cold dilute alkaline KMnO4 is called as Bayes reagent. This compound is used to detect the unsaturation in the organic compound, and it is used to estimate the ferrous salt, oxalate, hydrogen peroxide and iodide. For acidified potassium permanganate, we always use sulfuric acid alone, but not HCl and nitric acid, because HCl if we use means the HCl reacted with the KMnO4, the chloride ion oxidized to chlorine, that is HCl. In HCl, Cl minus is changed as a Cl2, minus 1 to 0 means it is oxidized, so the KMnO4 oxidized the HCl to chlorine, so that it never use HCl. The same way in nitric acid itself, it is a good oxidizing agent, so the nitric acid is used with reducing agent only, not like a KMnO4, but because KMnO4 is a oxidizing agent, so that we are using sulfuric acid for potassium permanganate as a acidified potassium permanganate means always using sulfuric acid as a acid. The next one, we are going to see the equivalent weight of KMnO4 in different medium. We already know we have in acid medium the potassium permanganate gain 5 electron. So I wrote the reaction here. An equivalent weight of KMnO4 formula, molecular weight of KMnO4 divided by number of moles of electron transferred. In acid medium, how many moles of electron transferred means 5 moles of electron, and molecular weight is 158. So divided by 158 divided by 5, we get 31.6. So equivalent weight of KMnO4 in acid medium, we get it 31.6. In alkaline medium, 1 electron is getting to transfer. See the equation. And equivalent weight is equal to molecular weight divided by number of moles of electron transferred. So 158 divided by 1, we get 158. In neutral medium, 3 electron is going to be transferred. So equivalent weight of KMnO4 is equal to 158 divided by 3, we get 52.67 equivalent weight of KMnO4 in neutral medium. So it is a important one word question, girls, or it is a 2 mark question also they may ask. So study it well.